Welcome to the next session, my dear friends. In the previous session we have discussed about the grit chamber. So in this session we are continuing the next system of the process, that is skimming tank. Okay, that is skimming tank. So skimming tank, the name itself says skim. Skim means cutting, trimming the top layer is called skimming of the top layer. See, when there is oil and greases present inside the water, okay, so when there are oil and greases which are present inside the water, so where there is oil and grease present somewhere in the water, then what we generally do is so we will be sending air from the bottom of this skimming tank. So we are going to send some kind of air bubbles into the skimming tank. So these air bubbles will collect all the oil and greases. Okay, it will collect the oil and greases present inside this water, So that oil and greases we will collect into a chamber. Okay, into a chamber. So here whatever the oil and greases which take the top layer, so these oil and greases will fall down into this chamber, By this way generally we remove the oil and greases inside the water. So we are sending the diffused air. Okay, we are sending diffused air into the system. So this air will collect the oil and greases present inside the water and take them to the top. Here it will form a layer of oil and greases which will be taken out, which will be removed by this top layer. So this is skimming off. Okay, so this layer will be trimmed by this jar and taken into this jar, and the water which is free from this oil and greases will go out from here, and this is the inlet. So this is the inlet and this is the outlet, and the top layer which contains oil and greases will be trimmed off here. So likewise the skimming tank will work. Okay, So the design, if you look at the design of the skimming tank, the surface area of the skimming tank, it will be rectangular. Okay, surface area of a skimming tank L by B. Okay, it is taken as 0.00622 Q by VR. 0.00622 Q by VR. Okay, so here so Q is the flow rate and VR is the liquid rise velocity. Q is the flow rate and VR is liquid rise velocity. Generally we take it as 0.25 meters per second. So the liquid rise velocity we generally take it as 0.25 meter per minute. Sorry, it is not meter per second, it is meter per minute. We take it as 0.25 meter per minute. So likewise we remove the whatever the oils and grease present inside the water will be removed in this manner. Okay, so after this skimming tank we use directly the primary treatment. Generally there will be sometimes deterious tank. So there will be another tank that is called deterious tank, which is like a grit chamber only. Okay, so there is another tank called deterious tank which is similar to grit chamber. Okay, so it removes grit. Some part of grit is removed in deterious tank and some part of grit is removed in the grid chamber. So in deuterious tank generally we remove finer organic and inorganic particles which are non-biodegradable in nature. So the deuterious tank is similar to grid chamber only, but the only difference is grit means removal of larger particle. Okay, deuterious tank means it removes finer particles also. That is the only difference between the grit chamber and deuterious tank. Okay, if there is very fine material, then we also use grit chamber along with the deuterious tank. Okay, so next is skimming tank. It is also over. So now we are going to discuss the primary treatment part. We are going to discuss the primary treatment part, that is primary sedimentation. Primary sedimentation. See here, generally sedimentation is of different kinds. Sedimentation is of different kinds. So in the water supply we have seen type 1 settling tank. So why we call a primary sedimentation tank in water supply is type 1 settling tank. Why we call it as type 1 settling tank? Because type 1 settling tank will have discrete settling. What is meant by discrete settling? What is meant by discrete settling? That means a particle when it settles, it will not disturb the path of the other particles. That is nothing but a discrete settling. Okay. So next is primary treatment. Primary treatment or first degree treatment, and the name of the unit is primary sedimentation tank. Primary sedimentation tank. So here primary sedimentation tank, if we go back to water supply engineering, we call this primary sedimentation tank also type 1 settling tank. Why we call it as a type 1 settling tank? Because there the particles which settles, that will settle like a discrete settling. So here types of settling, if you look at the types of settling, so that first one is type 1 settling. Type 1 settling. So type 1 settling is nothing but discrete settling. So here particle settles independently. Particle settles independently without disturbing other particles so that is nothing but other particle settling. So so when a particle is settling, it will settle directly, straightly like this. It will not go and hinder the particles of other path. So this is not discrete settling. So this is called discrete settling. Okay, this is called discrete settling. So this kind of settling we observe in primary sedimentation tank of water supply. So this kind of, generally when the particle sizes are larger, so when we observe this whatever be the sedimentation tank, this is type of settling depends on the particle dimension. It is depending on the particle property. So when the size of the particle is little larger, okay, when the size of the particle is larger, then in that case, when the particle size is larger, in that case we observe type 1 settling. Okay, for when the particle size is larger, when the particle size is relatively larger, so then in that cases we observe the discrete settling. Okay, in that case we observe discrete settling. That generally the discrete settling we look in, like grid chambers also we look the discrete settling, because the particle size will be high in the grid chamber. And also in water supply engineering, we observe this kind of discrete settling in primary sedimentation tank, and also in when the particle is settling discretely, we can apply Stokes law. Okay, when the particle is not having a discrete settlement, then Stokes law we cannot apply. So this is type 1 settling. Next is type 2 settling, that is flocculent settling. Type 2 settling, type 2, that is flocculent. See, flocculent settling means there will be a flock. So we can understand now flocculent particles. So they will bring the finer particles together and increase the mass of the particle. So by which they will settle faster. So earlier the particles are far away. So the flocculent will bring a flock. Whatever the flock will bring all those farther particles together and increase the mass of the particle. Okay. So this kind of flocculent settling we will observe when the flock is attracting the finer particles, and the concentration of that finer particles, if it is less than 1000 mg per liter, if it is less than 1000 mg per liter, then with the help of the flock we will see flocculent settling, and this flocculent settling we observe in secondary sedimentation tank of water supply. Okay, so we observe this kind of settling in secondary sedimentation tank. Secondary sedimentation tank of water supply. And type 3 settling, that is hindered or zone settling. Type 3, hindered or zone settling. See here, type 3 means this one. Hindering means obstructing the one path of the particle by the other path. When the concentration of the flocculent particles, okay, is intermediate, okay, is in intermediate range, they are close enough together so that the velocity fields will get intersect, they will get overlap, okay, causing hindering of the settlement. See, when the particle sizes is smaller and they are closely packed, then what happens? So this is the velocity profile of the one particle. So this is the velocity profile of the another particle. So now these two particles will having obstructions, intersections like this. One particle movement will hinder the other particle movement. This is nothing but a hindered settling. This is called hindered settling. Okay. So generally this kind of settling, this type of settling, when the secondary, we generally found this kind of settling in the secondary sedimentation tank followed by activated sludge process. So we will see this kind of hindered settling in secondary sedimentation tank after activated sludge process. So we will discuss that process again anyways. So here whatever the secondary sedimentation tank that comes after the ASP, we see this kind of settling. That means the particles will be very fine and their settling will be hindered. Okay. So we look this kind of settling in secondary sedimentation tank after activated sludge process, after ASP. And the type 4 settling means compression settling. Type 4 settling, type 4 settling, that is compression settling. See, compression settling means when the particle concentration is very high. Okay, so when the particle concentration is very high, then what happens? The particles will compress into a form of layers. Okay, so the bottom layer will support the weight of the upper layers. So that kind of settlement, for example, if the concentration is very high, then how the particles will settle? So this is the particles when they are at the top. So when they are settling, they will come together like this. So they will form layers. So these bottom layers will support the top layers. These bottom layers will support the top layers. So these particles will come and stick to this layer and gets compressed into a form of a unit. Okay, so this when the particle concentration is very high, then in that case the bottom layers will support the top layers and they will settle like a unit. This is called compression settling. This is called compression settling, and this compression settling generally occur when the particle concentration is very high. Okay, when the particle concentration is very high, and you will observe this kind of settlement at the bottom of the secondary sedimentation tank, followed by trickling filter or ASP. Okay, and sludge thickening. So in the sludge thickening also at the bottom. So at the top you will see hindered settling. After this hindered zone is completed, at the bottom zone where the sludge is accumulating, at that location in that zone, so we will see all the particles are accumulating into the sludge zone. So there you will observe this kind of compression settling. So here compression settling we observe in secondary sedimentation tank bottom. Secondary sedimentation tank bottom. So after ASP or trickling filter, anywhere. Okay, so secondary sedimentation tank bottom we will observe this kind of phenomena settling. So these are the different kinds of settling inside the sedimentation tank. Either it may be primary treatment or it may be comes in secondary treatment, because I told you already the first degree treatment we only consider the primary sedimentation tank, we don't consider the secondary sedimentation tank here. Why, I will tell you once we complete the processes. You will understand why we don't keep secondary sedimentation tank in first degree treatment, why we are keeping it in second degree treatment. So now coming back to the primary sedimentation tank, here the design of the sedimentation tank and the analysis of the sedimentation tank will be same as we did in the water supply engineering. How we did it in the water supply engineering, in the same manner here also the design, overflow rate, settling velocity, surface area, cross sectional area, depth of the settling tank. So all are same, finding them are same, efficiency, overflow rate, everything is same. So the only difference here is the detention time will vary, because the particle sizes generally in comparison with the water supply, here the particle sizes will relatively larger. So it needs lesser time, because it don't need a higher degree of removal here, because anyways we need to take out the BOD which is being settled inside the sedimentation tank. We need to take out and we have to treat it again in other sludge digester kind of equipments. So that is why here we don't give much time, because if you give much time, what happens, that sludge digestion takes place inside the sedimentation tank only, which we don't want. We want that sludge digestion to happen inside the sludge digesters. So that is why we have to give sufficient time such that it allows to settle the sludge. Okay, it allows only for the settlement of the suspended matter, so the biodegradable suspended matter. So it won't give time for decomposition of suspended matter inside the primary sedimentation tank. That is why the primary sedimentation tank, generally the design specifications of the primary sedimentation tank we keep here. So overflow rate, surface overflow rate, we keep it 30 to 50 meter cube per day per meter square. 30 to 50 meter cube per day per meter square. And flow velocity, detention time. So we keep it around 1.5 to 3 hours. We keep it the detention time here. We keep lesser detention times. Here inside the primary sedimentation tank of the sewage. Okay, and the flow velocity we keep it same as that of there. So flow velocity VH is equal to 0.3 meter per minute. So the same we keep in the water supply also. The same we will keep here. L by B ratio 4 to 5. Width or depth ratio, generally width is, we keep width as 6 meters. Anyways, the efficiency of removal is independent on depth. Okay, so likewise generally we design the primary sedimentation tank inside the sewage treatment. Now let us move on to the secondary sedimentation. Let us move on to the secondary treatment. So primary treatment part is over. Let us move on to the secondary treatment. So very, very important. From now onwards we are actually entering into the subject, because whatever we have discussed so far are just basics. So now the real importance of the environmental engineering in terms of wastewater is coming. That is secondary treatment. So I told you already, in secondary treatment there are many units: aerobic units, anaerobic units, suspended units, dissolved units, suspended units, attached growth units, suspended system units. So now there are different kinds of units. So we will discuss each and every unit and how to design that unit, how it works actually. All those things we will see. Now let us start with the activated sludge method. Okay, let us start with activated sludge process. Activated sludge process. See, what is meant by activated sludge process? The name itself says it is an activated sludge we are using. Activated sludge means, see, whenever we bring whenever we do the treatment, for example, so let us take an example by the flow chart of the treatment. So I am sending the inflow sewage, okay, into the primary sedimentation tank. So this is the primary sedimentation tank. Okay, so this is primary sedimentation tank. From here I am sending the outflow into the secondary treatment, that is activated sludge process. So this is activated sludge process, means it is a combination of an aerator. It is combination of an aerator, okay, aeration tank followed by secondary sedimentation tank, So this is the effluent. So this combination is called activated sludge process. This combination is called activated sludge process. So it happens inside the aeration tank and secondary sedimentation tank. How it happens? Why we call this as activated sludge? Because when you are sending BOD from here into the aeration tank, so whatever the wastewater that is coming from the primary sedimentation tank will contain BOD. So that BOD will enter into the aeration tank. Now here BOD is present, but to eat BOD, to destruct the BOD, we need microorganism. So from where the microorganism will come? Okay, so it came from somewhere. Now the microorganism is present inside the aeration tank. So now it is eating the food. After some time, we need to send all the wastewater out of this aeration tank, right? After some time, when sufficient treatment is completed, then what we do generally? We will send all the treated water into the secondary sedimentation tank. When the effluent is going out of this aeration tank, so all the organic matter, whatever the decomposed organic matter and undecomposed organic matter, will go from this aeration tank to the secondary sedimentation tank. Now here, so when there is no organic matter present in the aeration tank, so the bacteria will also not present. the bacteria, whatever the microorganism present inside the aeration tank will also go out of the aeration tank along with the sewage, okay, outflowing sewage. So now in this aeration tank, now there is no microorganism present in the beginning. So all the microorganisms are present inside the secondary sedimentation tank. Now whenever the effluent which is entering into the secondary sedimentation tank, we will allow some time so that the organic matter which is present inside the secondary sedimentation tank, we will settle down, okay, will settle down in the sedimentation tank. Okay, now here when the organic matter is settling in this, that means I told you already many times, so we treat carbonaceous organic matter here, we leave the nitrogenous organic matter out of the system everywhere. So now whatever the organic matter which is settling in the secondary sedimentation tank is of nitrogenous type. Okay, now so this nitrogenous organic matter, along with this nitrogenous organic matter, so the microorganisms will also settle down, Now so here there is no carbonaceous organic matter, but there is more amount of microorganisms are present. So here, so the sludge which is present here, where the concentration of microorganism is very high and the concentration of food is very less. Okay, so that kind of condition, so that sludge is called activated sludge. This sludge is already in active state, so the microorganisms are decomposing the organic matter, so that is called active state. So this active sludge, so whatever the sludge which is containing lot of microorganisms, that is called activated sludge. This activated sludge we will send back into the aeration tank. Okay, so we send some part of activated sludge to seed, because whenever the influent is coming into the aeration tank from the primary sedimentation tank, there the microorganisms may not be present that much, but more amount of organic matter will be present. That is why, in order to increase the microorganisms also, because we need both food and microorganism. Both, food means the organic matter, microorganism means the biomass. So both are important for happening, for degrading the sewage. So that is why here we will send the activated sludge from the secondary sedimentation tank in order to balance the concentration of microorganism and balance the concentration of BOD inside the aeration tank. So that is why we call this as activated sludge process. We are sending the activated sludge from here. And again, so here we will discuss the aeration, we will discuss the activated sludge process in detail. Okay, in detail, then you will understand the total flow diagram. So I will draw the flow diagram first, and then we will discuss all the parameters of the activated sludge process. So this is primary sedimentation tank. From this primary sedimentation tank, we will send the organic matter into the aeration tank. From aeration tank, we will send it into the secondary sedimentation tank. So from here, we will send the effluent. Okay, and from this sedimentation tank, we take some amount. We call this as returned sludge. Okay. In this returned sludge, we will take some amount into the aeration tank, some amount we waste it, okay, into the sludge thickener. We send this into sludge thickener, and then we send it to sludge digestion. Okay, so this is a sequence. So let us define all the terms. So here, whatever the inflow, so let us take it as Qi. Okay, so this is effluent, QE. the concentration of BOD inside the effluent, let us take it as Yi. The concentration of BOD in the effluent, let us take this as Ye. The MLSS, the concentration of microorganisms inside the aeration tank, that is X. The concentration of microorganisms in the effluent, the concentration of microorganisms in the effluent, let us take it as Xe. So this is returned sludge QR. Okay, and the microorganisms present in this, let us take it as XR. Okay, so in this returned sludge we are using usable sludge, let us take it as QU, and the concentration of microorganisms in the usable sludge is XU, and this is the wasted sludge QW, and the concentration of microorganism in the wasted sludge is XW. Okay, these are the different terms which we will use for the analysis of the activated sludge process. What is QI? QI is rate of flow into the aeration tank, QE is rate of flow out of secondary sedimentation tank. X, MLSS, that is mixed liquor suspended solids, that is nothing but microorganisms, concentration of microorganisms, that is X. XE, MLSS in the effluent. So this is concentration of microorganisms in aeration tank. This is in aeration tank, this is in effluent. Okay, and XR, QR, rate of returned sludge, XR, concentration of microorganisms in returned sludge, QU, rate of usable sludge, XU, concentration of microorganisms in usable sludge, and QW, rate of wasted sludge. XW, concentration of microorganisms in wasted sludge. Okay, so these are the different terms. These are the different terms which we generally use to analyze the activated sludge process. Okay. Now, so let us discuss the parameters. What are the different parameters that are necessary to understand in the activated sludge process? So these are all the various parameters. Using these parameters, we will understand the working, how the activated sludge process will work, and what are the different design parameters. So from these parameters we define some more parameters by which we can understand the working of the activated sludge process treatment. Okay, so now here, so there will be food. Okay, so there will be food inside the aeration tank, and with the time, so with the time in the aeration tank, initially the food will be very high. Initially the food will be very high, but with the time what happens, the microorganism will start eating the food. So now the food, with the time the food will get decreases. So this is called a food curve. So this is food curve, which represents the quantity of food with the time. Quantity of food with the time. And if you are taking the growth of microorganism, so if I am taking the growth of microorganism, if I am taking the growth of microorganisms on y-axis, growth of microorganism on y-axis, then so there will be different phases in the growth of the microorganism. There will be different phases. So the growth will be like this. The growth will be like this. So this is A, B, C, D and E. Okay. So AB, we call AB as lag growth. So the growth is very less. Okay. So that is called lag growth. BC is log growth. BC, log growth. Log means logarithmically, it grows very faster, exponentially. CD represents stationary growth or constant. Stationary growth or constant growth. DE, declining growth or endogenous growth. Declining growth or endogenous growth. So declining growth means once the food is over, then what happens? So the microorganisms will eat other microorganisms and survive. So this kind of phase is called endogenous phase. So that will occur in DE, because of which the growth is decreasing and reducing to the initial value. That means the bacteria or microorganism will feed on other microorganisms and survive. By that way, generally the bacteria will die away. So what are the different kinds of microorganisms we generally see in the treatment of the sewage? Not only activated sludge process, in various treatments we will find these microorganisms only. I already told you, aerobic, anaerobic, there are two types of microorganisms. If it is aerobic, okay, so that means it depends on oxygen. Anaerobic means it can work without oxygen. Facultative, there is another kind of bacteria, okay, that is facultative bacteria, which can survive in the presence of oxygen and in the absence of oxygen. So facultative bacteria, it can survive both in presence and absence of bacteria. Okay, and this is basic classification depending upon the availability of the oxygen, depending upon the temperature also. Okay, depending upon the temperature also there is a classification. So if they can survive at lesser temperature and higher temperature, okay, likewise we classified. So classification of microorganisms, classification of microorganisms based on temperature. Classification of microorganism based on temperature. Psychrophilic, mesophilic and thermophilic. So psychrophilic, mesophilic and thermophilic. So this is when it can survive only when the temperature is less than 10 degrees centigrade. It can survive when the temperature is in between 20 to 40 degrees centigrade. So it can survive at a temperature of 40 to 60 degrees temperature. 40 to 60 degree centigrade. So likewise, so we classify the bacteria depending upon the temperature at which it can survive. Okay, this is one kind of classification. Again, depending upon whether how it develops its food, like if it can develop its food on its own, okay, then it is called autotroph. It cannot develop, then it is heterotroph. Likewise, we classify, because generally the microorganisms derive food from the organic matter, so it cannot create its food on its own. Okay, based on food creation. If they create food on their own, okay, if they create food, if they prepare food, so that those are called autotrophs. Okay, those are called autotrophs. And heterotrophs, I already told you, generally the microorganisms are heterotrophs. Depends on so they cannot generate food on their own, so they depends on other, because here autotrophs are like plants, algae. So this is an example of autotroph. All the microorganisms, bacteria, all are examples of heterotrophs. Okay, bacteria and all, this is nothing but heterotroph. Okay, so this is the classification of microorganisms. Generally here, in order to maintain this, okay, so in order to maintain this aeration, so here in activated sludge process, in order to have the aeration, so where the aeration happens, in the aeration tank. So aeration can be done by two ways. One is completely mixed flow tanks. Generally these aeration tank is of two types, which is completely mixed flow type aeration tank, and second one is plug flow. We have discussed this already in the previous lecture during one question. Okay, plug flow type. So these are two types of tanks which we generally use in the place of aeration tank. Okay, so if you want to have extended aeration or tapered aeration, we use plug flow type. When the amount of discharge is more, so generally the amount of discharge in which we do the completely mixed flow type is very less, whereas in plug flow type we can go with larger amount of sewage also we can treat using plug flow type. Okay, we will discuss in detail, in brief, not detail is not necessary. In brief, we will discuss these two in the next class, and also we will discuss all the derived parameters. So independent parameters I have already discussed in the just now, what is Qi, what is Yi, what is everything. So from these independent parameters I will derive some other parameters by which we can understand the working principle of the activated sludge process that we are going to discuss in the next class. Thank you so much.